Please, I hope this works. This is so cool. Wait, look at the inside. Let's see if we can add sound to it. Oh. So finishing off from last video, we finished our 3 components that we need. First, we have to understand what we want the CPU to do with these components. So I'm going to create some instructions for the CPU to perform. Okay, this is our pseudocode. Okay, don't be scared. So this is a way of writing instructions to describe what we want our CPU to do. So the program counter is going to keep track of what address we're on, aka steps, so like 1, 2, 3, 4, 5. So let's magically connect everything together. Boom, boom. So every single time I press this button, it's going to increment the program counter by 1. So since we're on address 0, nothing is going to happen. Okay, nice. Let's increment it by 1 now. Okay, so the next address tells us to load register 1 with a 3. So let's do that. So step 2 says subtract register 1 with a 1. Okay, nice, that's gonna equal 2. Step 3 says jump if 0 to step 5. So since we don't have a 0 in our register, we don't jump. Step 4 says jump to step 2. So we're gonna jump to step 2 now. So step 2 says subtract register 1 with a 1. So now we have a 1 now. Jump if 0, no. And then we're gonna jump to register 2 again, and that's gonna actually give us a 0. Next step says jump if 0. We have a 0 now, so we can now halt, which means stop the program. Our goal is for our CPU to understand those instructions and actually turn that into hardware operations. So as we see right here, we have a lot of input. So for us to do one command, we would have to encode and press a lot of buttons. Okay, for example, let's try this one command. Let's load this pattern into register 1. So first we have the pattern, then we have to put the right signal, and also the right address, and then we have to press the button. And that's just for loading a number. For other features, there would be way more input press. This is where our control unit plays a huge role in this. It takes instructions from the instruction memory and converts that input into hardware operations. So let's give it a quick instruction. We're going to tell it to add R1 with a 2. Okay, so it's going to take that, organize the data, output it to the register, plug in the mini inputs, and direct everything. And now there's a 2 in register 1. So think of the control unit as like a traffic cop. It's going to direct the data to where it's supposed to go. You might be confused on how the control unit understands what operation to do, like add, subtract, and other things like load and everything. And this is how it works. So the first 4 bits are called the opcode. Basically like the mode you want to choose, like add, subtract, or load. And the rest of zeros are called operands. And it basically describes the data within that mode. So let's say these 2 bits wanted to like do RA plus RB. Say if you want to do that and put the result in RC. You can use the rest of the operands to provide more instructions and data. So I was working on my control unit and I was like, oh my gosh, this looks horrible. So what I'm going to do is break everything into small circuits and just add it together. Way better, oh my gosh. So I have almost everything for my control unit. I have an add mode, a subtract mode, blah blah blah. So we're just gonna connect everything together now. Yes, we finished everything in the control unit. Now, we're gonna add all our parts like the register, program counter, and RAM. So now we're gonna add more wires. As you can see, we have inputs for the register perfectly aligned. So we're gonna connect these together. And now we're gonna do that for everything else like the RAM, the program counter, and everything we need. Okay, let's start off with our first test. We're going to put this code into our register 1. Then we're going to tell it to store register 1 into RAM 1. Okay, nice. It's stored now. Now let's tell it to load RAM 1 into register 3. And nice, it's in register 3. That's perfect. Oh my gosh. Alright, since we're done with our CPU, we can do some cool things. So let's do some cool things now. Please, I hope this works. This is so cool. Wait, look at the inside. Let's see if we can add sound to it. Oh. Okay, let's see if this works. Let's go, man. Well, that's it with our CPU, guys. And I'm so happy we finished this.